Hi, welcome to the course where we're going to do SQL for data analysts. So this is going to try to make you kind of job ready on day one to be able to tackle simple and complex SQL queries. This is going to give you the fundamentals that you need to really write those SQL queries. That's going to be covering everything from joins, data cleaning, CTEs, subqueries, and the like. Um, I'm going to try to teach this in a very casual, slow way. We are going to set up a MySQL database. And as you look in most of the job postings, you'll see MySQL is um, one of the main database management systems that are being sought after. So let's get started. Let me just take you through the curriculum very quickly. All right, so we're going to look at a uh, real world data set, but it's been scrubbed and it's been made anonymous. And what we're going to do is it's going to be called loop and leaf. And then we're going to go over query fundamentals, joins, aggregations, all the things that I kind of mentioned just a few seconds ago. In addition, I'll give you some extras at the end. So let's start by first getting our database management system set up very easily, and then we'll move forward from there. Okay, here's the MySQL installer. I'll put the link in description for you, but you can just Google MySQL installer. This is going to allow you to download the installer. You can download the smaller version or the full version. A lot of times people have issues with the smaller version, so I'm just going to download the full thing. It's bigger, but you'll definitely have everything you need. So just click download. That'll initialize. And then you're going to be prompted to this screen where it asks you to log in or sign up. You don't have to do either one. Just put no thanks down here. Just start my download. That should download. Then you're going to open it up after it finishes download. Click the installer. And then you're going to be prompted. Now that you click the installer, it's going to ask you, do you want to make any changes? Then you're going to be presented with this window. And it's going to ask you what you want installed. Um, you could just click it. You'll see MySQL and or any of these. I'm going to click the shell and put add. And now you'll be presented with all of these different applications. So we definitely want MySQL Server, and you can see it's a tree. And what this is going to give you all the versions. Let's get the latest one here, which is 8.0.46. And then you just click the arrow to push that over. I'm going to close that up. And now I'm going to get MySQL Workbench, which is actually the application that we use on top of our server. So I get the application here, and I go to Workbench, and I'm going to go to 8.07. Oh, that's a new one. You might have. Let's try 7. 6 should be okay, but let's try the new one. So I'm going to get that, push it over, and then close that up. Now you could get all the documentation in the router, all this stuff if you want. It's not needed for this particular use case. So I'm just going to hit click next. And you can see those two are being loaded, which is Workbench, which is going to be the GUI or the application that sits on top of your actual server. Now you can see that I already have this path that exists. That's because I already downloaded this previously and deleted it. So my view here might be slightly different to yours. So I'm just going to get click next, and I'm going to be presented with this warning. You probably will not. and then it's going to be say ready to install, and then you just hit execute, and it'll take a while to install. Now that both of these are complete, just go to next, and then it says ready to configure, hit next again. This is just going to give you your overall information on the server that you're going to be creating and the port. I'm going to just click next and just get the defaults. This talks about authentication and encryption. I'm just going to use a strong password. So I hit next. Now it's going to ask you to put a password. I'm going to add mine. And then you can check it to see if it meets the standards. Passed. Hit next again. Now this is going to show you your service name. And I'm just going to use a standard account. Hit next. And then execute. And this should update everything. You can hit finish. And then go to next. Now you can launch MySQL Workbench. So I'm just going to go to finish down here. And then it's going to launch MySQL Workbench. This is just showing you what you have installed. Okay, there we go. So this is going to be the platform that allows you to connect to your server. So you can see down here, this is your local instance with that MySQL L80 that we said that was there. We are going to just click that, and then it's going to ask you for your password. Enter your password. Hit OK. Now, my view is going to look a little different from yours because I have some installed database here. So you can see here are all the databases I have installed. Um, we are going to build a database in our next section here. And you can see that we'll be able to name these. They call schemas in MySQL, but you can think about them just being databases. And then we will be adding tables into our database. Now that you have your server set up, we are going to create a database. So if you're thinking about the structure of a server, your server would be something like a department store. Within that department store, you would have specific departments. Those would be your database. And then within those departments, you would have aisles with specific products. That would be your table. So now we want to create a new database. So you can navigate over to the the left side of your screen. And you can see where it says schema. Schemas are a name for a database within this MySQL structure. So you can see here are all my different databases. They have different tables within them. And you can see they have tables and views. So let's create a new schema. So you're going to right click anywhere there. You're going to go to create schema. And I'm just going to call that your store. Actually, I'm just going to call it store. You can call it whatever you want. And then I'm going to hit apply. And now we're going to be given this screen. And one of the ways you can create a table is with create schema. So we can do that directly within our query box. But this way it does it for us. So you can see this is reviewing our SQL script. So you can create SQL tables this way. Now, most of the time in a job, you're not going to be creating any tables unless you are a IT or database management um, person, but you are an analyst, so your job is to retrieve data. So let's hit apply. It executes that SQL and finish. Now you can see that you have your store. Now within that store, let's just click the arrow. You can see tables there, but there is nothing there. Now what we can do is we can go here and we can import our particular files that are going to be our table. So there are multiple ways you can do this. So go to table data import wizard. Then I'm going to go browse, and then we're going to navigate to where you have your data. So then we want to navigate where you have your files for this course, and those are going to be all the individual CSVs. These are all of the tables here. You will need to bring these in individually. There is a way to do a bulk upload, but it gets a little bit messy. So I'm going to bring in all these individual tables. So I'm going to start with orders. You can see that brings in from the path. Go to next. We can see it creates the table names with the database called store, and then order, and then go to next. Now this is going to be where you configure the individual column data types. As you can see here, we have integer and text. You can change these as needed, but this looks fine to me. You can change those with the down arrow here. So just go to next. And then you can see it prepares and then imports our data. If there's no issue, it should fill up and you should be able to import this quite easily. You can see it says finish performing that task. Go to next. Go to finish. Now we can hit this button here, which is refresh. Once you have that refresh, you can go to your orders. And now we have that table in our database that we created. And then you can select the first 1,000 rows here. I'm just going to initialize that. And you can see we selected from store.orders. So you can see that's database plus the table. And what we're going to do is continually add all our tables to this database. But before we do that, let's just do a quick walkthrough of what you see here. This is your SQL query. This is your grid or table results. And this is the log that tells you what has been initiated. You can see we created a table, and then we did a query to pull from that table here when we selected the first 1,000 rows. So you can even see the query initialized. All I want you to do is go over again, and you're going to continue to add those tables. Let's just do one more very quickly. Very quickly, table import wizard, returns. So here is the corrected import. We want to go over, and then you can see that here you have return date. Now, you can change it to a date time if you would like. And let's just do that for an example here. So I'm going to change return date to date time. And you can even set the format here. So we don't need the minute and seconds or the hour. We just need the return date. So now you have that. We go to next. We go to next again. And now we import that. It's imported. Finish the results. We go over, hit refresh. Now you have returned. We can select the first 1,000 rows by right-clicking, select first 1,000. And the return date still has our 0 zeros. I'm not really sure what happened there, but that's fine. We can always do a cast to change that. So we're going to continue to bring in those tables, and then we're going to start writing our queries. Okay, so you have your database and server set up. Let's take a look at how those tables are connected. And we do that with an entity relationship diagram, ERD. And a lot of times you will have this provided to you by your database management system administrator, or you sometime have to figure this out on your own. And the way you figure it out on your own is you use the primary key and foreign key. Now, don't let those terms confuse you. You just want to know that a primary key is just like a unique identifier. It's something like the region ID that you would use to connect to another region ID column in another table. So we connect tables with the columns. The primary key is something that's not duplicated, it's unique. And you can see from this diagram how these two tables are connected. For example, let's look at regions and customers. I know in my region table, I have the region ID, the region code, the region name, country, and continent. If I wanted to join that table with the customer table, I would use my primary key to connect to the region in the customers table. Now, you know that there are going to be many, many region IDs that are duplicated in your customers because you're going to have many customers with the same region ID. However, in your region table, we're only going to have one of those that connects. So we do that with a join. We're going to see many examples of this in the examples that we jump into when we start querying. So now one strategy I hope you can take from this training is that you are here to answer business questions. So if someone asks you to bring back information, you want to try to make sure you're answering a question. So remember, we're using the loop and leaf database. We just saw our ERD. Now, ERD is the revenue is growing. We want to know which categories, regions, channels, or reps are driving that growth. So you want to think that in this course, we're going to answer questions. So regions and customers tells us who is buying, employees, who sold, products, what was sold, orders, and items. Those are going to tell us the individual transactions, and then returns, what was returned by the customer and why. So we're going to answer all those questions throughout the course. So let's dive in. So we're back in the database management system, and we are looking at MySQL Workbench. And as you know, we created our database, have our server up, and we did a select on the return table. Now you should have brought in all your tables and be ready to go. So I'm have selected everything. So this star here is called a wildcard. That means it brings back everything. And then from, so we know it's retrieving the data. And then from our database called store, we're bringing back the return table. And this semicolon indicates that the query is over. Now, if we wanted to change to another table here, we would just change to, let's say, products. Then you can see that IntelliSense open up, and it shows you that it's a table. You can hit tab, and that should finish off that. And you now can run this query. So here, if you press this lightning bolt, this means that it's going to run. So we can also navigate up here, and you can go to execute the query if you want, and you can see how the shortcuts are, the current statement, or you can go Control Shift Enter to do what you've selected. But this icon is pretty useful. So now we have a query. Now we're bringing back all our columns, but what if we wanted to bring back one column? You would just bring back something like the product name, which would be one of the columns. And you can see as you type, as you type in MySQL, the IntelliSense will pop up. So I'm going to bring back product name. Maybe I'll bring back the list price, maybe, or the cost. Let's say list price. And now, if we just run this, we can bring back the information here. We will only bring back these two columns, but let's continue. Now, one thing to do is that's pretty nice is to format. So you can just press enter to bring back the columns. As you see here, I put a comma to separate these columns, but you wouldn't put a comma here. Now, I am bringing back the product name, the list price, and maybe I only want a particular subcategory or category. So what if I say I only want products that are from the kitchen? Now that is called a filter. We use where for a filter. So we can say where, and then we select the column name, so category, and then we do equals, and then now we know that that value is text. So we want to put it in quotations. So I'm going to say bring back everything that's in the kitchen. And this is going to select the columns from your database and table. And then we're going to filter those results to only kitchen. So let's run that. And as you write your queries, you'll be prompted to see if you have any errors. So I'm going to run that. And you can see we brought back product name, list price, and then just to make sure we have only the right category, you can bring back the category. Remember to put your comma here because we're bringing back another column. We don't put the comma after the last column. So now I'm going to run that again just by clicking that icon. And now you see you brought back only kitchen. Now we have a lot of results here. We can use the word limit to say bring back only maybe 5 results. Run that. And now you have 5 results. Now we can also use order by. So limit is usually going to be the last part of your code. So let's use order. Maybe we want to order by something. So sort. So let's order by the list price. Now we can order by highest to lowest or lowest to highest. And we do that with another little keyword there, which is descending. So let's look at this query. What we have done, we've selected the product name, the list price, and category from our database and table. We have filtered using the category column, and we said anything in that column that equals kitchen. We ordered descending, and now we only want the 5 results. So think about what that's going to give you, and think about what question that's going to answer. So we run that, and this is literally going to give us the highest list price in the category of kitchen, which now we have an answer, which is silicone and spatula. Now, what if you wanted to flip that and we use ascending? What do you think it's going to happen? This is going to give us the lowest to highest in the category. So that is a query that you can put together to answer a question. Now we can also put a docu string here. You can put docu strings with either 2 dashes, so we can say the lowest. I think it's 2, and it might, yeah, lowest list price. And a lot of times when you're answering questions, what is the lowest list price in our product category, you could just bring back 1 and run that, and that's only going to bring that one back. So we can literally copy this and then put that query there and run that, and then you can have these 2 queries together. And let's put descending here. Now, some database management systems will allow you to run both of these at the same time. I'm not sure if MySQL will, and it'll create 2 windows. I don't think MySQL does that, but let's see. And you can see I was wrong. And what you get is this error here because it's saying that you have 2 queries running at the same time. If I put a semicolon there, you can see that error goes away. And now I run that, and only the last one is going to run. So it's running in order. So you have to take that in mind when you are bringing back the results. And you can see its lowest list price. This is going to be the highest because it's descending. And you can think about maybe you want to add another filter there, right? So maybe you want to bring back 10 results here. And maybe you want to say oh, sorry, not here. We want to bring back a filter and maybe the list price is greater than 100. So now we don't need this. So what we're going to do is double dash that. And what that does is it turns this into a docustring. And we probably don't even need this because we're going to be bringing back results. I am going to just highlight that with my cursor, and then I am going to run it. So now this one will run, and you can see we bring back only kitchen results that are greater than 100. So these are different ways for us to filter. So now let's dive into the practice and the homework to see what we should do with our query. So we have kind of covered a lot of querying fundamentals. As it states, every query starts with choosing a column, filtering rows, and controlling the order and size of the result. So here's something we've already achieved. Here's the business question that you might get from your merchandising manager, where you would use different codes and keywords like select, where, order by, and limit to bring back the 5 priciest kitchen products we want to feature. As you saw, this is what we did in the previous section where we looked at the product name, the category, and the list price. We brought those columns back. From the product table, we filtered that category with kitchen, and we ordered by the list price to get that in a descending order, and then we limit 5. So you can see that the clauses or the keywords that you have used already are listed there. But now I want to dive into the homework section just so you can move forward if you would like. And we will also move a little faster now that we covered the fundamentals. So let me just go over to the homework. So here's the homework that you will be doing. You can already move fast and skip ahead if you need. So the first question we have is pull the cheapest products in the storage category. I'm pretty sure you can do that, and I'm pretty sure we have done that. So you should be able to do that. Joins, we're going to find customers who have signed up but have never placed an order for a win-back email campaign. We're going to list every sales rep next to their manager in our self-join. And self-joins are not that important, but I want to put them here because you will sometimes see these in interviews. We're going to do aggregations where we find the product in categories over 15% discount. We're going to talk about subqueries, where we can find the customers whose total spend is above their overall average customer spend. We'll talk about window functions by ranking each rep by revenue with their own region and kind of exclude that company-wide categorization. And then we will get the monthly return rate trend for kitchen-only categories. You could definitely move forward and dive into those if you like, but let's just dive back into MySQL, and we could just answer this one really quickly. I think you already know what we need to do, so let me just pop over to that. And if I fail to mention all the answers for the homework, I will be including, but definitely move forward and see what you can do. So we want the 5 cheapest list price is list price products and the kitchen category. And you can already see we have the lowest list price where we're bringing back the product name, the list price, the category, and kitchen. We have the list price here. And all we need to do is run this. And this would be the griddle pan. So we're going to start diving into the next section. We're going to move a little faster, but now you know where the homework is. The answers also will be included with the queries. And so I think we're ready to rock and roll and move forward. So let's continue with the topic of filtering. We can do quite a lot. So I am going to just take all of these. I'm going to press Control A. And let's just start with a fresh query. So let's do select star from store, which is our database dot, and let's do order. Let's do orders. No, I don't know. Cost orders. Yeah, orders. And all right, we run this. We should get all our data back. So now let's do some filtering because we have a date. So we know we filter with where, and we know that we can do this operator called equal, but we can also do one called in. So let's say, what if we wanted to look at a channel and we wanted to bring in two options? Now, of course, you could do where channel equals and channel equals like that. And then we would put what it equals. But you can also do it with an in operator. So like this. So we can say we're in, and then we put our options in there where meta ads, as we see there, as channel. And let's say organic search. And I don't know what the quotations are. They might be single or double in MySQL. So let's find out. And let's see, make sure those quotations match. Okay, so we run this. And now you can see we're only bringing back those two. So that's one filter. We can also continue to add a filter, right? And we can say we want the date between. So maybe we just want the date between, let's say, order date underscore date between, and you can see that I'm usually capitalizing all the SQL operators. So I'm going to put date between, and I'm going to do 2025. Let's say 0101, and let's go to, now with between we need to add and I keep putting two different quotations there for some reason, so let's use a single one. And I'm going to say and I'm just going to copy this over to make it easier. Let's say, so this looks like month, year, month, date. And I'm going to say everything before, let's say, the 14th. Okay. Let's run that. And now we can see that we have all the dates before the 14th there. We can continue to filter, and you can see each one of these filters. I'm adding and. Now we can see the employee ID here is not necessarily all complete. We can see there's an empty space, and that's called a null. So I can say where employee ID, and you can see that IntelliSense pop up. How about I say is null? Now you can also do is not null, but let's just bring back null because it'll be a little bit more interesting to see. is null, where employee ID is null. But I just saw something. Let's run this one more time. Oh yeah. Now, let's run this. Okay, so it looks like some of the nulls after 14. Well, that actually should pop up. Well, let's get rid of some of these conditions. Uh, so as you see, when I run and null here, we don't bring anything back. It's empty. Now let's figure out why. What I'm going to do is I'm going to put all these conditions here. So where channel is, and then this one, and then I'm going to get rid of this and here just by commenting it out. And now, so where employee ID is null, let's see if we bring anything back. No. How about is not null? Yes, we bring everything back. So these are not nulls. What these are spaces. So that was not a great example. So what we can do here is say where employee ID equals, maybe we do blank like that. Let's see if that brings something back. Yes. Okay. So those are not nulls. Those are actually blanks. So okay, let's take off these filters. Um, and now let's run this. Okay. So now we're bringing back information from employee IDs that have the channel that is empty between the dates of 2025 01 and 2025 01 14. Now we can still do more, but let's just run another query. So what I'm going to do is I press Control and the backslash, which will comment everything out. Let's look at another channel. So let's select everything from products. Okay. Now we can see there is a lot of different products here. Maybe we want to find everything that starts with a certain word. And let's see if we can find, let's do, we see towels and we see throws and blankets. So what if we wanted to bring back anything that has a T? So we can say where subcategory like, and then what we do is we use a percent to say anything before. So if we want to say anything before a T, we would do that. But if we want to say anything after a T, we would put the T in the front. So let's run this. And now you can see that we bring back anything that has a T, starting with T. And you can see this can get quite interesting in your filtering. So those are some different ways to filter. So let's jump over to our PowerPoint and just kind of review. Here we are in the database management system. Let's comment out our last query and let's just bring in the customer table. So bring in from a database store customers. Customers. Is it the customer table? Yes. So I'm going to run that. And you can see we have several columns here. So you can see we have a customer ID. And then we have that first name, last name, and more information regarding the customer sign up. Now, we don't have any information on the orders for that particular customer. So I'm going to now just copy this and let's look at the order table and let's see how we can join those. And you can always reference the ERD. So I'm going to look at orders, and remember these are going to run sequentially. So we probably should just run this one, orders. Let's just highlight and run that one. There we go. We have order ID and we have the employee ID and the customer ID. So as we saw in this one, we also have a customer ID. Now we know this customer ID in this table for my ERD is unique. So we have a primary key there. We want to join, so we use the keyword join what? We want to join this table. So I'm going to just copy this, join that table. Now we have to think about how we want to join those. Now, we can continue to write these out store.orders, but we can also give this what we call an alias. So I'm going to say C for customer and O for orders. And then now we can join those on C for customer underscore ID, I believe it is. Yes. And I'm going to say equals O dot customer. So what we have essentially done is join those two columns. I'm going to get rid of this for right now, just with Control C. And then I'm going to run this. So that looks like it's fine. And let's just bring this back like this. So from the customer table C, we're joining on the customer ID on each table. That should work. Let's see if we have any issues. Nope. So that has essentially brought back all of the data that is connected to both of those tables. Now you might be asking yourself, okay, what kind of join did we just do? And are there different types of joins? And there are. There's inner joins, there are left joins, there's full joins, there's outer joins. However, in your day-to-day work, you probably will only use two types of joins, which are inner joins, and most of the time it's going to be a left join. Okay? So now let's kind of look at a couple different joins. Let me bring this image in here. And you can see there are varying types of joins. There's an inner join. And by default, when you use, a lot of times, I can't say every time, when you use just join, it only brings back the inner join. We usually have to indicate the type of join we want. For example, left join, a right join, left join where. You can see we can do it with a filter where there is nulls or is not nulls or full outer join. The majority of the joins you're going to use are these two. So let's kind of explore this. This is going to bring back everything that matches on both tables. So if there's data that is not in one of the tables, it will not be brought back. This is a left join, which means the main table. This will bring back all the information on that matches that main table, regardless if it's in the other table. And this is just the opposite of that. So let's kind of explore this a little bit. So let's just bring back C. Now that we have aliased those tables, we need to bring back the columns indicated there. So C is first name coming from the customer table, and O is the order ID coming from we remember the order ID is in both tables. So let's bring back the one that is in our orders table, just in case uh, there's some information in there that we don't have. So let's bring that back. What happened here? Something. Oh, is this it? Oh, oh, we need a comma. Sorry. So a lot of times when you put these on the same row, it confuses me. So you kind of want to format this where you can kind of see what's going on. And you can see this brings back just those two rows. And nothing is blank because we used a inner join. So that means that we want information from all tables matching. So what if I put left join there and I run this? And now let's see if we bring back any information that is empty. Doesn't look like it. That means that all our customers have their own information where is there. But what we could do, we could probably add a filter here. So the filter is going to go at the end. And remember, um, we might not have null. So where order ID equals, let's do our empty string there like that. Let's see what happens. Where order ID equals, oh, and we need to say which order ID. So let's from the orders table. Now let's run that. And it looks like there's an error. What is the error? Ah, is there an error? Let's run that. Okay, error code where for order ID. So you can see I had a misspelling there. There we go. And now run that. And now we should be good. Okay, so there's nothing where we don't have an order ID with a left join, or we can say try is null. Oh, actually, we do have some that is null. So here are the nulls. So you can see what I've done here is I've left join, so I don't care if this information is in my order table. So I'll bring back the nulls. So what I've done here is I've done a left join, which brings back all the information that matches our main table, which is customers, regardless if there's a matching record. So these are the nulls. So we see that these are customers by their first name, at least, that don't have an order ID. So they haven't ordered in a sense, according to this logic, because their information here is null. And if you wanted to do is not null, that means we would only bring back the customers that have all of uh, the rows that we have orders in. So those are the types of joins that necessarily are going to be the only ones that you are going to be using. Okay, so let's think about joining multiple tables. So I'm going to comment this one out here and like this. And then again, I am going to use let's use order items. So order slash items. And there we go. So we have order items. And let's run that. And there are order items. So let's just go ahead and alias that table for fun, call it OI. And let's join that to get some information from the orders table. So we can say join store.orders. I think, yeah. And We want to join that on. Oh, and let's make sure we alias order. So we're going to bring that, connect those with the order ID. So OI dot order ID. There we go. And equals, and I think I'll just get rid of these. We don't need those. Equals O dot order ID. And we did on OI. Oh, sorry. Equals. All right. There we go. So let me make this capital just so it's easier to see. So what are we doing? We're bringing back everything from the order ID table, connecting it, doing a inner join, and we can call that inner join now that you know which one it is. And let's join. So we're going to be bringing back that information. If I run it, should be good to go. So now we see we have this long table because we connected those two tables. We have a channel that has some nulls in it. Let's continue to join. Let's join the customer table because we know customers have order IDs. And let's call that C, and let's join that on C.customer ID. And then we see our order table here has a customer ID. So let's say O dot customer ID. So O dot customer ID. So now look at what we're doing. This is our main table here, right? This is our main table here, our order items table. If we just look at the order items table, we know that we are bringing back the orders table, and now we're bringing back the customer tables. We connected the orders table using the order ID, and we connected the customer table to our order items table, to our orders table. We connected our orders table to our customer table. So let me explain that a little bit better. Here is your first join. So that is bringing back, and let me just show you. Let's see, inner join. Okay, yeah, we should be able to run that. So this is the resulting table. Now we can join another table that has one of these particular information. And because we see that we've brought back the customer ID, now we can join this resulting table. So think about it as a new table to the customer table. And now we will get this information. So I'm just running that. And something went wrong there. Customer ID. Let's see. Should be running. Okay, there's an inner join on. Let's see. So we got join. Let me format it this way so we can save some space. Customer C. What did I do wrong here? So orders, you got to bringing back everything from the orders table. Order, store.orders, store. Oh, store.customer. So we didn't have the database there. Hopefully that's it. Yep, that was it. So I'm glad I'm making these little errors so you can see how they are fixed. Um, So now this is our resulting table. Let's go wild and do one more. Enter join. Let's join regions because we know customer has a region. So let's say R, and then on, let's say R dot, what would it be? Region ID, I believe. Now I'm just going, I remember the ERD, but don't hesitate to pull that out if you need to. Region ID. Okay. Because customer was the last table, that's the one I'm joining on. Now let's run that. And I did the same mistake, store dot. And the reason I keep making that mistake is because some database management systems, you don't have to continually write the database name before. There we go. Now, typically you wouldn't bring back a big table like this. You want to bring back some information. So I'm going to bring back this big table here. And now I'm going to say, okay, I have this table to select from. Maybe what I'll do is I'll see what is the revenue for the regions. So we don't have anything that has revenue in here, but we do have quantity and unit price. Now let's look at bringing back the information we want. R, which is the region, join, right? So let's bring back the region underscore name. And now let's bring back the sum. Now this is an aggregation. So sum is going to tell us or what the particular aggregated value is for this region. So we are summing it up. So let's sum the OI, because that's that main table, and the quantity. And let's call that as total items, maybe. And now, when we use an aggregation term like this, we also need to use a group by. So what we're doing is grouping by that particular region name. So r.region underscore name. And then we need to put a comma there. So now if we run this, now we can get all the items for that particular region. We can also say, okay, I know we have unit price, so let's get the average unit price. And let's call this average, average price. And put a comma. And something's not right, it looks like. Oh, no, it was right. Okay, so now we have the region, the total items, and the average price. We can also say, okay, this is too many spaces beyond the decimal. So we can do another statement here and wrap this into a function called round. And now we're going to round this whole thing, and we only want 2 decimal places. So now let's run this. And now, why is that not working? Let's see. Oh, the wrong, because we put it on the wrong one. Okay, so let's bring that down here and bring that down here. Okay, now we should be able to run. Okay, there we go. So now we have the total items and the average price. Now what we want is the revenue. Now we wouldn't multiply these two to get the revenue because this would be average price and the total items. We want it at the row level. So we would say we want to sum the OI quantity, right? Times. So now we can even do multiplication inside this. OI unit price. And now we sum that and we call that as revenue, right? And we would probably also want to, let me put a comma here. We would also want to round that to the 2 decimal places like we did before. And now we would have the items. So at the line item, we have the revenue. So at each one of those rows, we are multiplying quantity times unit price. And let's put a space here. Quantity times unit price. And then we are summing it. Then we are rounding it. And then we're grouping it by the region. So it's going sequentially. So let's run this. And now we have our revenue by region, average price for the region, and the total revenue. And how did we get that? We got that through doing these multiple joins to get there. So if you look back at your ERD, this is how we got that. Usually it's not this, you don't have to make that many joins to pull things together. But I just wanted to show you that you can use multiple joins. And while we're at it, let's organize this. So let's order by revenue. We might be able to do revenue now that the whole thing has run. Revenue and descending. So a lot of times this column needs to be created with this query before you can use it outside of the information. So let's see if that works. Yes, it does. So we can see that Mid-Atlantic is the number 1 revenue producer with $26,676.69. So let's pop over to our information PowerPoint to kind of see what we covered and then look at the homework. Okay, so what did we achieve there? Now, remember all queries start with a business question. So I need the total revenue broken up by region for Monday's board deck. Okay, so we know we can pull that. We know our ERD and we know the connections that we needed to bring back. We have order items, orders, customer, and region. We brought that back. Here, I did not add the inner, but by default, it's an inner join. We brought back the region and the revenue. In our example, we brought back average price and the total quantity. But this is going to give you a easy way of answering this question. So you would be able to give the VP of sales the total revenue broken out by region for the deck on Monday. Let's go down to our homework. Where is it? Where is it? Where is it? Here we go. Join. So find customers who signed up but never placed an order for a win-back campaign. Find customers who signed up but never placed an order. Now you got to think about what that means. Something is going to be missing. So I want you to look at how to answer that. And you can definitely, I will be giving you the answers, but you really should try to be finding this out on your own. Let's go and talk about the self-join. Okay, so before we jump into our self-join, can you tell me how would you filter this table? Now, this is going to be important. We're going to dive a little bit more into this later. But what I want you to think about is how would you filter a table that has already been aggregated? We cannot use where because where happens in the unaggregated table. So that's a filter that allows us to filter data before the aggregation occurs. However, after, we would have to use having. So now there's an order here. We need to have having before the order. So I'm going to pull this down here. So what, oops, one side, oops, and let me turn this. Okay, so what if we want to say having an average uh, price greater than, let's say 117. Now let's see if this works. So what we're going to do is run this. And you can see what happens is we get a price that's greater than 117. So that's just a way for us to filter. We wouldn't be able to do this if with a where because we need to apply this to our current aggregated results. So we're going to dive a little bit into that later, but let's just keep that in mind when you're thinking about the difference with having and where. Well, maybe it's better to dive into that now, but let's skip that. Okay. So let's quickly go over a self join. I'm going to control slash that. Oops. Let's say control A and then control slash. So this is going to turn that query into a docustring, so we can't run it. So now we are going to look at the employees and managers. So this is a very common interview question. You don't run into this a lot, but I figure I better show you guys. And plus, we can learn a few extra functions in SQL. So let's pull up the employees table, which is our um, table store dot employees. And then what do we want to bring back? Let's bring back everything. So that wildcard, I run that. And you can see what we get is our employee ID, the last name, and all that information that we want. So now what I want to look at is joining that to the manager's ID. So now you have to think about this. What are we joining at that point? Because we can see that there's a manager ID here. So we would literally be joining the same table. Now, a lot of times you don't have to do this, but again, let's go ahead and do it. So left join. And what are we going to left join? Because we just want to find who is the manager. So I'm going to say employees. Oops, store dot exactly the same one. But now we can start pulling the tables that we want. So we know we're going to left join because we want to pull back everything that's in that left table. But first, let's identify what we are doing. So the employees would be aliased as E, and the managers would be aliased as M. So now we have, even though we're pulling from the same table, we are using an alias to separate things. So now let's pull the first name of the employee. So first name, and now we're identifying that employee with the alias E, and then the first underscore name. So think about it. What if I pull back another one, the name, first name of the from the manager table? So I make a what do you call it? A comma there. So we have that. Left join store employees on, and let me make a space. So now we know on E.manager. So we want to know the employee from the employee table. Who's the manager for that employee? So we do manager ID equals the employee ID. And let's see what that gives us. Is that all good? I believe so. Let's run that. No, we have an error somewhere. Oh, we have an alias this. So we're going to call that our manager table. And now let's run this. Still, we have an error. Let's see what it is. First name, blah, 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 from the employees table E. Left join store.employees M on E.manager. Oops. They're both employee IDs. So you can see I made a mistake there by thinking ahead when there's no such thing as a manager ID. So now let's run that. Okay, so now you can see I got two first names, Morgan and Morgan, Jordan and Jordan, Taylor and Taylor, right? So you can see that that name is just repeating that. Now what we want to do is we definitely want first name and last name together. So we're going to use concat. And we're going to, concat allows us to add two things at once, but I want a space between those names. So I'm going to put a space here, and then I'm going to put E dot last name for that employee last name. And that's going to be as, now we are aliasing the column. So we're using as, so as, let's call that a rep. And, oh no, let's call it an employee. And then now let's do the same here for this one. We're going to concat, and you can see that pops up. Concat, and it's a function, so it's always going to have this parentheses with it. And then let's do m dot last name, and we call as a manager. Okay. Let's see if that, any issues there. Oh, we don't need a comma there. Okay. Okay. So now you can see this is repeating. Now we have to say, okay, if we want to be able to bring back who the manager is, we need to ensure that there is a filter. So we have the first name, the last name, we have the manager, and this. So now we want to be able to say who is the manager. And the way we're going to do that is one with our join. So we're bringing back employee on employee. Let's bring back the manager ID equals employee and see what happens. Okay, so now you can see there's a null here. That means Morgan doesn't have a manager, because we can see if we're joining the manager IDs to the employee IDs, we're able to see who the manager is. So Morgan is definitely the manager of many. Jordan Hayes is the manager of many. And then Cassie Reyes is the manager of many employees. So this is a way for us to just join the same table on top of each other. It's not anything special, but you will get these in interviews. So I just wanted you to be aware that you can join the same table. So as you saw here, this is exactly what we have achieved. We created a self-join where we have joined the manager ID to our employee ID. So essentially, we just identified a manager in the same table we had. Now, in this request, the business request, it says for the new org chart, can you list every sales rep next to the manager's names? That's what we did. However, we didn't identify sales reps, and you can see here we can easily do that with a where. Now, there's no aggregation happening here, so we use where for the filter. Now, we did see in our previous query, where is it, about aggregations and grouping. So we broke down the revenue, and we got the average. We didn't get the average discount, but this is what this is doing. So you can see break down the revenue and average discount by product category for the monthly close. Now, we did something similar here, but we weren't doing answering this particular question. So let's see how they uh, would bring back this information. So all of these are aggregations: count, sum, average, min, and max. So let's look at this SQL query, because sometime when you are having to add to these queries, you need to understand that what's going on. So we are counting the total number of items sold by just counting the rows. This is what this a wildcard is doing. We are summing the quantity times the unit price and then rounding it as the total revenue. We are rounding the average discount percentage, which is a column, in the average order in the orders items table, and then we just bringing back one rounded, and we calling that average discount. Then how did we get there? We joined the products table equals the product ID. That's how we got the category here. Then we grouped by the category, and then we ordered the revenue descending. So that is grouping everything. So let's see what's next. This is where you have to pay attention to where you're going to put a filter. So if we wanted to look at the row level of the unaggregated the results that we didn't change, just pulling from the table, we use where, which is going to allow us to filter things. So you can see where discount price is greater than 20. Now, if we aggregate or use an aggregation like we have done before, we need to use having, and that's us taking those results and filtering those. So sometimes you can use the instead of having average discount, you would alias this as a name and then add it here. But sometimes you actually have to use the aggregation depending on the database management system. So having is filtering aggregated results, while filter that we use for unaggregated results are where. So next we're going to dive into CTEs and subqueries, and this is going to be pretty important. Okay, let's dive into creating subqueries. So we already know what a query is. For example, we can maybe select from, and let's do store dot order, maybe order items. And let's take a look at that. If we run everything in there, we can see we have a unit price. Now there's going to be an average of this unit price. So what if we wanted to get the average of the unit price? So right now I'm going to just copy this query, and then I'm going to say, give me the average of the unit price. So average, and then unit underscore price, and make sure we have, all right. And let's just comment that out for a second. So we get the average of the unit price. This is a singular value. So what if I wanted to bring back all the information that had an average, all the information that was higher than the average of the unit price? And the way we would do that is with a subquery. So for example, let me uncomment this. So control, should be able to do it this way. Control slash, and then we have this subquery. So now I can say, give me everything where, right? Because that's our filter, where the unit price is greater than this query. Now, the way we make this query run first is to encapsulate it in these these quotations, not quotations, these parentheses, like this. So that means it will run first. So now if I run this, I only bring back unit prices that are higher than the average unit price. And that's essentially what a subquery is. So let's look at what is called a CTE. So in this case, I think a subquery is fine. But sometimes when you have more complex information or more complex queries, you don't want to be filling it up with CTEs, with subqueries, because it can get messy and hard to read. So CTEs aren't better or worse than a subquery. They just allow things to be much more organized. So let's take an example of this. Imagine we do a query that has a join and things like that. So uh, let's do one of the examples we did before. So let's select from store dot. We could stick with order items. Order slash items. And we already know what's in order items. We can see that here. But wait a minute, do we have order date and order items? Let's see. We can go over to the side. I want to show, let's order items. Okay, let's do a join then. This is a good example. So now let's join the orders table. And let's say store.orders. And then we alias those tables, right? So let's call this OI and call this O. And let's join on OI dot order ID equals O dot order ID. Oh, order. works. Okay, and I'm going to go ahead and comment this one out, this subquery here. Okay, so if we run this, we get that information back. So what if I wanted to say, hey, let's do some aggregations. So maybe I want to group by the order date. Oh, this is interesting. 25. Oh wow, we have mixed. Is that a mixed vat? What is going on there? Let's do some exploration. Order date. So now I'm going to look at the order date, and we can get that from, well, we don't need to actually alias that, I don't believe. No. Okay, that's interesting. That order date is wild. It looks like something got mixed when we imported it. Hmm. Because my idea here, date format. Let's see, and then let's do order date, and then let's do something like this. Let's see what happens. All right, so what I'm getting is year and month, and I'm saying as month. I don't know. We may have to force that. Okay, yeah, so that works. So let me explain what I just did. We had a column that looks like we had mixed formats. So, like I said, this is kind of real data. So people have created mixed formats. So what I did was I took the column and then I forced a date format on it. Instead of um, the date, I put a year and month as month, and you can see what that has given me as month. And what I'm going to do now is say uh, we can also get, okay, maybe we can remove this null. We already know how to do that, right? Where month, I don't think we can do month. No, we can't. So we can say, we can copy this, is not null. Um, okay, so now we have all just the month and the date, and let's see if we it looks like we have 4 months. Okay, so just to review, we saw we had a mixed format date. We forced the data type by using a date format here, which is a function, turn that into year and month, and now we filtered out this information that was null. Okay. Now, we have that. What else do we want to bring in? We want to bring in, let's bring in, let's see what's in order items and orders, because I don't want to run it again. So we can always come over here. So quantity, unit price. So I'm going to do another one of those. So let's say revenue, right? So let's get the sum of, oh, well, let's do quantity. What are we doing? OI equals um, times, is that both coming from order items? Yeah. And what is it? OI dot unit price. And we want to put that in parentheses, so it runs first. And as revenue, put a comma. Okay, let's see what happens. So now we have the revenue after we've created this join. So this is a way of doing things. Now we can continue to work on this, right? So we could say sum, and then we can get the sum of the revenue, and then now we can group by. Now we can group by, let's say, let's take this where out for the moment. So we can do that with the double quotations, and let's group by. And that's the group by, see if we can group by month because it's running first. Let's see what it says. It says select month. Oh, wait a minute. I shouldn't have to have two of these because we're already running it inside. So should be fine like that. Yeah. Okay. And also let's round that, right? But make it look a little bit better. Round and then 2. And now we run that. Okay. So let's review what we've just done here. You might be asking, why did I use date format here instead of using month? It really depends on the DBS. Sometimes once the query runs, we can use the alias, and sometimes we can't. So you may have to switch depending on the database management system and how the query runs. So now we have this table, right? So now that we have this table, and we can also add one more thing, right? Instead of where, we can say, because I believe we have nulls here, right? Yes, there we go. So we can definitely pull that back, but we may actually want to see, hey, we don't have a date on that revenue. Uh, so that is another thing what we can do. So now that we have this column, so let's leave the null there. And we have this table, right, that is running. So this might be of interest to someone. So once we have that table, maybe we want to select what's the average revenue. Um, we want to bring in the average revenue per month and only want to bring back the months that have a higher than overall average revenue. So we would need to query this and then add a subquery. So that seems kind of complicated. So what we're going to do is we're going to make a CTE, and it's essentially like a temporary table. So let's call this our I don't know, monthly underscore revenue, and then as, and then I can encapsulate this into this structure here. And let me pull this down. Can I pull this down? Yeah, let's pull it down a little bit. All right. And then now that is there, I can just select from the monthly revenue. And then of course we can just select everything from that. All right, we need to put this here because this comment is blocking it out. Okay, so now this is encapsulated. Run that. You see, all you're doing is selecting it from there. So this could be your table that you've created, and this would be maybe like a transform table that you have. And then, of course, now you could say, where Revenue is not null or null if you want it. But let's now get the average of this. So I'm going to create another query here. And let's see what the average is. So let's see, I'm going to just comment this out very quickly with control and backspace. And then I'm going to say, give me the average revenue. Now we have to remember that we have this empty space here where we don't have any data. So if I get, the average is going to be influenced by this. So if I say, give me the average revenue, let me pull this up a little bit. Average revenue from our monthly revenue table. Okay, so that's the average revenue. Now, what if I want to bring back results from my monthly table that have the average revenue that is higher? Now, remember the revenue will change if we have that null. So we would need to think about that. But I'm just going to show you that, hey, now that we have that, what can we do? We can say, I want all the results that have a higher than average monthly revenue. And the way we do that is with, and then I would say revenue, revenue greater than, and then I would say, hey, give me the revenue that's greater than this. And let's format, let's see, average. Did I call it? Where? There we go. So now we're selecting from this temporary table that we've created from the monthly revenue table where revenue is greater than average revenue from a monthly temporary table. And those are the results that you would get. So those are the months where we have higher than average revenue. Now, of course, if you wanted to eliminate that null month, we could do that in our query. You could do that either, you could think about where you're doing that. You can do that after the aggregation or before the aggregation. So remember, if you do before the aggregation, you need to use where. If you use after the aggregation, you need to use having. So this is just an example of using a CTE. Now you can see why do you use a CTE? You're not going to get better performance or anything, but look how readable that is. Here's the monthly revenue table. Here's everything that we did to create it. And then here's us selecting from it. And now it makes sense to use a small subquery, right? Because we can see what we're doing. And then you can always add a comment there. Higher than average monthly revenue. So now we can get into the next stage would be window function. So let's jump into that. But first, so I just wanted to show you the difference in the average there. So let's get over to our PowerPoint. So here we are at a subquery. Remember, every query starts with a business question. So here's a request from your loyalty team. Who are customers spending above the company average? I want to build a VIP list. So now let's look at what happens. So you really need to be able to break down these queries. So we want customers. So we know we need to have a join to um, a customer table. We want the first name and last name. So we get that from customers. So that is the first part. Now, where, let's say the average, so this is going to be the main part, right? This is what we did. We just didn't add the customer information there. So now we want to select from where we have an average revenue, because we can see it's the quantity times the unit price from order items that are greater than the overall revenue. So let's break this down. So we have this singular query here, which is just the average revenue. We are only bringing back the average revenues that are higher than this. And then now we're selecting the customer and information from here. And how is customers connected here? You can see that we did a join to bring that customer ID here. And then now we just select from these two queries, right? So these are two subqueries. You might be thinking, how could I do this with a CTE? Now, I think this subquery is a really good example of, okay, you can read it. It's not too complicated. But we could clean this up with a CTE. And I want you to think about how you could clean that up as a CTE. Now, here's a CTE example. We did something similar. It says, okay, we need a request from our operations director. Which months came in below our yearly average? Now that's below. I want to flag them for the QBR. Okay. So let's break this down. We have a singular subquery here where we bring back the average revenue. We know how to do that. You saw us do this in our practice. So very easy there. Now what we do is create a CTE where you see what we did here. We get the date format where we get the month, and then we get the revenue, and then we have joined the order to the order table to get that order date. And you can see how easily readable this is. So I encourage you to go back here and see how we can clean this up and make it a little bit more readable with a CTE. Now let's review want some of the homework questions, not the answers, but I want you to just keep in mind that you should be going through and doing the homework. Okay, here we go. So you should have been doing joins. You should be able to do that pretty easily now. You should be able to do a self join. You should be able to do aggregations. And now you're at subqueries here. So you should be able to do all 5 of the homeworks. And all of these are business questions that you should be able to break down and put into a subquery. So I hope you are not having too many difficulties doing that. Just send me a message if you are, and we can review that. So before we jump into a window function where we're going to do some ranking and lag and the running sum, maybe we will also want to take a look at the previous query that we have created. So in this query, we know that we've handled that null by filtering it with having. We could have done it with where before the aggregation, but let's take that out for a moment. And then you can see this comment string is going to comment that parentheses out, so we need to add it again. And now let's run this just to get the null back. Okay. So imagine you say, hey, we cannot eliminate the null. We cannot filter it. So then let's see what we have to work with. We have this query. So if I highlight this query, we have everything grouped by month, right? Everything that is in that category for month is grouped. So what we could do is add a case statement. So we have us pulling in the date format and then us pulling in everything. Now, we could do this a couple different ways. We could say, we could pull our case statement here. So I could say, and what is a case statement exactly? It's an if. So if something. So if I say case, when, this is equal to if. So if the month or case when month is null, then, and then I'm going to put a, let's say this is, we could say even if that's like no date, right? No date. Else, give me the month. And then we end that statement as month. And then that's one thing we're bringing in. And also we need to bring in the revenue. All right. I think that's pretty good. Let's see. Let's run that, see if we have any errors. No, we don't. So you can see what we have done is we're able to keep that aggregation using a case statement, which is essentially just an if. Now, case statements are important and you're going to use them a lot. So I definitely just wanted to make sure you have that in your arsenal to use. And you can use a case statement in many times. And as we solve the real world, problems, we are going to use a case statement. But let's jump into a subquery. Okay, let's do a not a subquery, a window function. So let's say we want to know who is making the most revenue. So let's say we select um, who. So who, we need an employee name, right? So from the employee name, we can get this from the employee table. There's a first and last name, and there's an employee ID. So let's get that first and last name, and I'm going to concat that. And then, uh, and let me just make sure you understand what I'm doing. So from employee, from store.employee, employees. Okay. So, and then I'm going to call that E like that to alias it. Then I'm going to say, let's get concat the E dot first name and E dot last name. And we will call this, we'll call this as name. So that gives me, oops, oh, we need a little space there, right? Okay, there we go. We have the name first and last, and then we want to know who's making the most money. So if I bring this up, we know to get revenue, we need order items, unit price and order, unit price and the quantity. However, the employee table is not connected to order items. We need to go through the orders table. So we already know what direction we need to go in. So let's join orders, store.orders on store. Oh, sorry. And let's call that O. And let's join that on O E dot employee ID equal O dot employee ID. So we know we can join that. And then now we need to join the orders table. So let's join the order items table, order items on, and maybe it's let's OI, and maybe to give ourselves a little bit more room, let's put all that on one OI, and we would say O dot order item, order ID, I believe it is. Yes, order ID, order item equals OI dot order item, order ID. That looks like it runs. So let's see what happens. There's something doesn't exist. Table doesn't exist. So we wrote something wrong. Order items. Looks like that's it. Yep, that runs. Okay. So what do we want from that table? We want the sum of uh, we want the sum of OI dot quantity times OI dot unit price. It's price times quantity, and we can call that as revenue. Now, remember, anytime we do a aggregation, we need to use a group by. And now we need to group by everything that's in there. So let's group by first. Maybe. Well, number one, I want to group by the employee ID because that's going to be unique. Then I'm going to group by first. I don't know if I can do this, but let's see. Concat. I'm going to see if I can then group by this. Not sure if this is going to work. Uh, so let's see. Oh, it did work. Okay. So what I'm doing is I'm grouping by the employee ID because it's unique. You might be able to get away with just doing this as it's unique, but if you have duplicate first and last names, you're going to have an issue. So it's always better to do it with something unique like the employee ID. And let's round this so it looks a little bit better. Round, and then put the 2 here. Okay. So now we have who makes the most revenue. It's not ordered, but what we're going to do is instead of ordering it, we're going to get a ranking. And the way we rank is with a window function. And a window function essentially allows us to split the data into groups and then order it by some function. So let's create a ranking. So the way we do this is with rank. And rank is a function on its own. So that's the way we do it. And then we want to tell it what is the order, right? Over. So we want to say over is also a function, but we're going to add things to that function. So what we can do is order by, we say let's order by the sum of what we just put together here. So then we're going to order by the revenue because we don't have the revenue there. And we want that descending, and we'll call that as sales rank. Okay. So let me see if this, what else do we need there? I think that's it. Okay. So then you can see here is the ranking. So let's review what we did. And then you might be thinking, hey, maybe I could have done that with a window function, with a CTE where we ran everything first and then we put the ranking after. That's also a way to make it cleaner. But you can see, what did we do? We ranked, that's the function. And then we gave the ranking one, we gave it what to rank, the revenue. Then we ordered by that as how we wanted that ranking to happen. So that is essentially how we build a ranking function. And now you could say, you could do something like a CTE, like with sales ranking table as, and you could select from it. I just want to get you used to selecting from here and creating CTEs. So select everything from sales. Let's just copy it. Sales ranking table from where sales rank is uh, sales rank is greater than, well, let's say less than, right? Less than 10. So we get the top 10 ranking. Now we could do this. You didn't need to do all of this. So this would just give you the top 10 most successful salespeople. But you can see what you could do with a CTE. We can see it's very easy to read, and that gives us an indication on what we want. Now, that is one type of um, window function. There's another one we can do that I think you should learn, and this is just going to be lag. So let's see. Let's see if we can repurpose one of our queries above. So this gives us, I believe, the uh, revenue per month. Does it? Let's see. Select date. Yeah, this does. Um, I'm going to group by month. I'm going to see if I can repurpose this and put it here. And I actually don't know how to uncomment in MySQL, so leave a comment below if you know how to do that. I'm sure there's a shortcut. Okay, so what are we doing here? We're selecting the date format, turn it into months. We're getting the revenue, and then from order items, we're joining. This actually should run, and maybe we can get rid of that. So I'm just going to highlight this and run it. Okay. Oh, and then let's also get rid of that. So having, I don't want that one. Having, can I use month? Having month, uh, no. Let's see if this, okay. So now we have this, and we could put our I want to do a lag in this, so I'm going to call this our monthly revenue, like we did before, monthly revenue. And now I have this CTE that I can work with, so that's your temp table. And then let's say select uh, everything from monthly revenue here, month revenue, that's fine. Um, all right, so, and if I run this, should all be good. Okay, so now what I want to do is I want to get the previous month by and see what the growth is month over month. Okay, so the way we would do that, and group by, is this ordered? Ordered, ordered. Yeah, it's ordered correctly, so I don't need to put an order by. So the way I would do that is I say, okay, give me the month, give me the revenue, and that's going to be here, revenue. I think that's spelled right. Give me the month, give me the revenue. And now let's create, um, I want the previous revenue. So let's say lag. This is another window function. So you got to think about this as you want to get the previous information. So now I can say lag, right? So what do I want to lag? I want to lag my revenue. Um, then I use over again. Then now I create my part, uh, how I want that ordered. And we don't need to partition this because we're not splitting the data up, right? Because we're not splitting it up by anything here. So order by, and then we say order by month. And then we call this as previous. Oh, let's just put prior and prior revenue. Okay, and put a comma there. And now we just run all of this. Oh, we got an error. What do we have? Something revenue. Okay, it looks like. What do I call it here? As revenue, it should be. It's not in there. Oh, I see. Spelled it wrong here. Um, Now let's see if we can run it here. Hopefully. Okay. So you can see we have that prior month revenue there. So this was the revenue for this month, and then it's the prior. So now you might be thinking, what can we do with this? So we already have the lag. We can copy this now, and now we don't need as prior. But what we can do is a calculation, right? We can get the difference. We can take the revenue and minus rev. I don't know why I'm having so many issues here spelling revenue. And then now we're going to subtract the revenue from the previous month revenue and call that as difference. And now we can just run this. Hopefully no errors. Nope. And we definitely need to round that. Let's round as 2. Okay, and now let's run this with okay. So now we have the previous month revenue. So we can get a trend, right? Like um do we have this growing, or is it different over the previous month? And now we can go one better. Let's do one other window function where we take the information here. We have difference, and then we sum. What are we going to sum? We're going to sum the revenue, and we're going to say over, and then we're going to say order by month, order by month. And I want you to tell me what we are going to end up with. Okay, let's see. We don't need a comma there. Round. Order by month. Let's see what happens. Okay. Please tell me what is happening here. We have taken this information and let me round it so it's I know this query is getting kind of long, but it's very important for you to understand this. So we have a CTE where we have brought in the monthly revenue and we made sure we didn't have any nulls. Then we added a lag function to make sure we could see the revenue from the previous month. We also took the difference, and then what is happening here? Uh, so we have revenue. So what is happening here? You see 2000. We just take the first three letters: 244, 201, 244, 446, 446 plus 230. You can see it's a running sum. So let's round this and then put a 2 and then call that as running sum. So you can see how you can really add a lot of information. Oops, I shouldn't have run that. I shouldn't have hit that. It'll run. Let's see. There we go. Okay, so we have a running sum. And of course, if you wanted to get rid of these nulls, you know what to do with a case. You can put case when null, 0, else, give the revenue or the running sum, whatever column you're using. This is our running sum. Let's review again our window functions. So we know that when we're using window functions, we add our window function, lag or sum. We over, and then we tell it what to order by. In this case, we ordered by the month for both. We can go deeper where we want to do partitions. I don't think we need to worry about that at the moment. Um, but these are the two most common window functions I see people being used. And I hope this gives you a little bit of more certainty around that. So let's go for a bonus here. Since we're in the window functions, let's see if we can find the representatives ranked within the regions. So we know we have where we have it. I think we did a sales ranking table here. So let's repurpose this. I'm going to copy this. I think I just need it up to here. And then what I'm going to do is come back down here. I'm going to put a semicolon there to indicate that that is over. And now we have this query. So let's run this again just to, one, make sure it runs and then give you an idea of what's in there. All right. All right. So there's our ranking. This is ranked over the total uh, of the data set. Now, what maybe we want to do is bring in regions. And the region is in the employee table. So we've selected a name. Let's also get the region. So say e.region, maybe what is it, region? I can't remember what's in there. Let's look at employees. Uh, region ID, let's just use that, region ID. And we're also going to have to group by that. So let's go ahead and write that in there. E.region ID. And now instead of ranking and ordering by um, just by the revenue, let's also split it up. And the way we do that is with partition. So partition by, and what we're going to do is partition by that region. So e.region ID. And I don't think, there we go. And let's capitalize order by just to keep everything consistent. Order by. And now we have the sum, and we have descending, and we're going to call this as ranked region. Let's call that, or region rank. And let's see what we have here. Now there's a little error you can see here where it is. That's because we're missing a comma. So what this should bring us back is the first and last name. We're rounding the revenue. Then we're ranking and getting that total rank. But we should be bringing back the region and then the rank by that particular region. Then we have joined all of the tables I think we need to. So let's see what we get. Okay. So here's a region ID. And here within that region, we can see that there is a rank. James Turner made $9,817.15, while Skylar Blake had 9,600. So this would be the top, and this would be the second. Again, we have the top, second, and third. Top, second, and third. Now, sometime if they're only in one region, you're only going to get that one, as you see here. So this is a way to use partition to rank within something. So that's our way of splitting the data a little bit more. So you should be pretty familiar now that we have done a few window functions where we have used rank, row, lag, and also use partition within our window function. So let's look at this request from our sales leadership. Rank every representative total revenue company-wide. Now, company-wide would indicate that we don't need to partition the data. It's across the whole company, not by region, which we just saw an example of. And then you should be able to do this quite easily. We have done the same as you see there, and we have grouped by employee ID, first name, last name. We have joined those two tables, which were we needed to get to the order ID through a certain set because we know that we're pulling from the employee table. The employee table is linked to the orders table, and the items table is linked to the order table. So that's our join, and we are doing inner joins there. And there's our rank or our window function where we ranked over all of the revenue descending, as you saw there, as sales rank. And then we also brought in the revenue. So that is pretty good there. Let's go to the next set. And then we lagged where we looked at the previous sale, where we were able to get the previous month revenue. This should seem very familiar. There is a CTE there where we created that month aggregation. So there's a group by, which we know if there's an aggregation, we need to group by the month. And then we just select it from that, use the lag window function where we lag the revenue over ordered by the month. We did not partition because we didn't need to. We want the total as the month over month changed. Then we got all of the revenue and ordered it. And then we did the same with a window function where we ordered by the month. And then we got that running total. So that covers like 90% of the window functions that you're going to see. Now, what we need to do is dive into the last problem. But before I do that, I want to talk about this problem and talk about how to approach it. So now we're going to solve the last problem. We want to know, is our return rate creeping up, and is it worse in specific product categories? I need the trend, not just a snapshot. So we're going to break this problem down a little bit. I don't want you to see. There we go. Let's look into that. Let's look at like breaking this down. So here are the 6 questions that we can ask ourselves. What's actually being asked? Is the return rate rising worse in some categories? That's what's actually being asked. What is the grain or granularity of the data? So we know orders and returns are at a line item, and so we need to know that that is not the whole order. What tables do we have to join? We can look at our ERP. So we got order items, orders to get the date, product to get the category, and then returns for the outcome. For which which join type are we going to use? We're going to use a left join because most items were never returned. How do we measure it? So we're going to create a case statement, as you saw, and we're going to do things like using is null and look at, because it's a rate they're asking for, we're going to be looking at multiplying things by 100. And then how is the trend? We're going to group by category and then the month in the year. Okay, so let's pop back over and jump into this. So I've added the question here. It says, is our return rate creeping up, and is it worse in specific categories? I need the trend, not the snapshot. So I sometimes hate getting these type of requests because like we do need to break it down and kind of get an understanding of what's being asked here, right? So we know we need returns. So let's start there. We do have a returns table, so I know I'm going to be selecting from there, but let's just take a look at the columns in the return table there. So I'm going to click over here and look at columns. So we get a return ID, we get the return date, and we return reason and to order my item ID. Now, okay, that's good, but we also need to know the how that's connected to the order date because we need to know the trend. So let's look at our ERD. So let me see if I can make this a bit bigger. Oh, come on. All right, so Uh, we need order items, which are here. That's connected to the return. And then there we would get the order items, and we need the order date also, as you see here. This also has, what else do we need? We need it says within certain products. So we have the product and the order items. I think we can start with that. So we're going to get the order items. We're going to get the product category from the product table here. And then we're going to get the order date from orders. Okay, so this is the tables. All of these tables we're actually interested in. So the first thing I'm going to do is get the order items from the order ID table. I'm going to get the category for that order ID, and then I'm going to get the order date. And then let's look at the returns. Okay, because we want to connect those two. So let's select uh, everything from store.order items, and we know we need to join orders in order to get the order date or also connect to these other tables. So orders connects to order items to get that order date. And then order items is going to connect to products and returns. So let's do that. Right. So let's join orders. We can interjoin, and I'll write this out for us just so we know. Interjoin. We're going to just interjoin because those should be connected to orders. So interjoin or store dot orders O, and I'm going to put OI for this. OI uh, on OI dot order item order ID equals O dot order ID. All right, and then we know we need to join that one. Oh, we can just interjoin the product ID because this is just information on those products. Well, it doesn't matter. Store dot product ID. Oh, sorry. Interjoin store dot product. Is it called product? Products on p dot. What do we connect? Product ID. Product ID equals what is it? We're connecting this to the order table or I think let's look here. So I'm going to go into products. We know it's product ID. Order items, columns. Okay. That's employees. Sorry. Order items is here. Order items. Okay, that's what a product ID is, an order item. So we got to connect that one to OI, product, um, product ID. And then the final join, we need to get the returns. So we need to left join OI, right? Yes, because that has the information. So left join a store dot uh, returns are on OI dot or oh, how are they connected? I don't remember. Let's see. So we have order item ID as the primary key, and then returns we have or okay, so we can connect order item ID to order item ID there. So that is the column. So let's go back. Order item ID equals p dot order item ID. Now, I'm not going to bring everything back because it's going to make a really long table. What do we want? We want the order item ID, I believe. That is going to tell us which items are going to be returned, right? And this is OI, not OT. Okay, that should be unique to the table. And we said, let's look at creeping up. It's worse than before. Is it worse than before? Categories. So categories is let's see. I think that's in products. Columns. Yeah, that was a category. So P dot category category, and then we wanted the order date. So O dot order date. Okay, now let's see what we get. We need to clean this up. We have an error somewhere. Okay, let's see. Select is somewhere at the top. No, we probably don't. Let's put a semicolon. Okay, we put a semicolon there and it stopped pulling the error there. Let's join. Oh, let's see what we get. See if there's any errors. Run. Oh, there's an error. So select P category. What is table doesn't exist. Store. Oh, I spelled products wrong. Products. There we go. Hopefully that fixes everything. It looks like it does. Yes. Okay. Well, why are we getting region rank? Oh, sorry. The previous one is running, so let me run this and see what's going on. Highlight it. You can comment that out and see what happens. There is another error, unknown clause on so order item ID, P dot order item ID. Left join store dot returns. Oh, something's going on here. Left join store dot returns are on. Oh, look at this. This is wrong, right? That should be an R, not a P. All right, so let's try again. And still we have another error. OI product ID. Looks like I spelled product again. Yeah, you see, I'm making many mistakes here. Sometimes it's better to let the IntelliSense do it for you. Okay, so there we go. Now we have our query that runs. So let's see what we're returning. We have the order item ID, we have the category, and then we have the order date. Um, Now we want to be able to say, um, is our return rate creeping up as it's worse? Specific product category. So right now we don't have the return rate, right? So these are all of the order dates and we need to find the returns. So we need to bring in the return ID. So one way to do that is just bring it in, type return ID. And now we are bringing that in. So I'm keeping all these in a line. We probably shouldn't do that, but we need space. So let's see what happens. Okay. So return ID, right? There's quite a lot of nulls there. Um Now, so we don't want to bring back the ones that are null. We want to bring back the ones that are not null. And we can see here, right? Here's the ID. So now what we can do is say, okay, case when, so this is what we did before, case when return ID is not null, then one else zero. End as returned. Okay. And I think that should work. Boom, 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 boom. Case our return ID is not null, then one. Um, okay. Let's see if that runs. We're just going to highlight that, run it. Okay. Now we're in business. Now we have our table, right? So why not turn this into a CTE? So with returns, we shouldn't call it return. We should call it item returns as, and then we encapsulate this. And now we can select all we want from it, select everything from item returns. Okay. And I'm actually going to go ahead and close this off. I'm going to, if you guys don't need, I don't think we're going to need this again, but let me just control and get rid of that for a sec. So now if I run that, we get everything back. So now all we need to do is sum by the month, right? And by in category, so we know we want to bring in, let's get rid of that category. And you can see I'm not writing the table alias anymore because this is the table now. So I'm going to get the category. Let's make the month with date format, date underscore format, as we did before. And what are we going to do? We're going to bring in what is the order date? Is that the one we're bringing in? Order date, yes, order date. And then we want to make that into, what is it like that? Um, Not T, we need Y for year. Capital Y. And we'll call that as month. And okay, so now we need the average, right? Average returned. Okay. And because we have an aggregation, we need to group by the category and then the month. All right, and comma there. And that should be our query there. Here's our CTE. Here's our table with the month. And let's also order by the category and month so we can see the trend. All right, I should be able to run this without any issues. I know we have a lot of code up at the top. So let's run this. Okay, see if we got any errors. And we do not. Okay, so now we have a rate, right? Average returned. We still have this null here, but we can get rid of that. But let's not worry about that right now. So here is the returns for Bath for 0, 1. And here is the return for 0, 2. So it went from, let's multiply this by 100 to get the percentage. Because it's a little hard to see that way. Multiply by 100, and then I know we need to round by maybe 1, right? Just one significant digit. And then let's call it as percentage. And I think that's be okay. Run that. Okay, so there we go. So we have 8.5 to 0 to 12. So that's so we can see that is kind of increasing because the last month is 25% and we started the year at 8%. So that's definitely increasing. Um, if we uh, go here, and now we could use this whole table here and then print it and export it out and visualize this in Excel. Here is the living room. So let's look at that. Started out at 9% for no month, 11%, went down, down, down. Okay, there's definitely an increase. You can see that by the end of 2026, that return percentage is really high. So that is something going on with our business, and we can report that back to them. There is a trend of an increase, and we would, write this up and possibly add a table here, like maybe a pivot table in Excel, and then give that back to our management. So this is essentially what we did. This is a culmination of what you've learned. We have been able to use a CTE, a case statement, used our ERD to do multiple joins, so we could count uh, or count the number of ones that are not null to bring back our returns. And then we were able to use an aggregation to sum that and then trend that out by using the date format and Y and month because it was at the day level. So you definitely have achieved a lot, but let's keep going. So we know we followed these steps to get our break down our business request into a SQL query. So this should make a lot of sense to you now. And those 6 questions will always help you kind of break things down. And these are the steps that you can definitely use. So let's look at a few more things. So, what are the job ready extras? Because now the information that you learn should be able to allow you to be ready to do your job on day one, not without any problems or things you would have to look up maybe on ChatGPT, but it will definitely give you all the skills you need to be able to feel a level of fundamental confidence that you can do your job. So, here is a few things that you could get asked about indexing. You want to avoid select and star. You want to be able to bring back the specific columns because select and star is really not preferred. We did that a lot in the beginning. We have very small data sets, but large data sets, it will definitely kill your compute and also cost you money. Um, we did in, but there also is an exist. You remember when we said select category in and we put the 2? Exist is a little bit better for large data sets. You want to filter as early as possible. So I taught you how to filter with where and having. So the reason you want to do that because in big data sets, the more you filter way up or early, the less data you're pulling back. Um, the query really should be readable. And be able to be executed. So if you pass that to someone else, they should be able to read it really easily. That's what a CTE is for. And filtering and things like that early on will allow you to reduce some of the compute power. So you could get a question about that. How do you reduce that? So these would help. For your code quality, CTs are better. Use short, consistent aliases, as we saw OOI, CR. You don't want to use like a whole name because that defeats the purpose. Keep a consistent style, as you saw I did for our SQL codes. I used capitalization and name columns clearly, like average discount, not just average. This is important a lot because you might need to ingest that table again, and it's important to have a clear name that you don't have spaces and things like that in the middle. So here's some interview patterns. If you wanted to find the nth highest value, you can definitely use order by, limit, offset, which is about the same. And then dense rank. You saw rank. What dense rank does is if you have a tie, it will go to the next value. You want to be able to find duplicates. You can just group by and having to find that. Like just group, if you want to find duplicates in your table, you could group by, first name, last name, customer ID, and group by that and see what the duplicates are. Running totals and moving averages are really important. We didn't do a moving average, but I think you have an idea how to do that. It would definitely be with a window function. Month over month is really important, and so is cohort analysis. Self joins on dates is also something that is similar. So we have done a little bit of those. So for some career information, you want to always restate the business question back to the person that asked it. Break it down and do sanity checks by saying this is what you found. You want to get comfortable moving between different syntaxes. We're looking at MySQL, but BigQuery, Snowflake, Postgres, they're all kind of similar, just slightly different syntax. Document with document string what you're doing and make a lot of comments. And then, like I said, in the end, we always want to visualize. So you can visualize in Excel or do Looker or Power BI. And we could always connect that. There's a lot of ones on the channel that do this, and just look through the channel or comment below about what types of projects you want to see connected to SQL. Now, just if you're wondering about an index is just a way for you to create, um, like a way for you to reference different um, different data in your return table. Instead of scanning the whole table, you can use an index. You are a data analyst. You're probably not going to have to worry about that, but I just wanted you to be aware of it. So I'll leave this in, and you can do some research on it. So homework, I just want to go over that very quickly. Here's all the homework. You should have a real new problem. You should be able to do window functions, subqueries, aggregations, self-joins, joins, and the fundamentals. I have all the answers here. You really should try to do this without the answers. And um, but I would encourage you to try to do everything without the answer. Um, And that's the summary. So I hope you're ready. Any questions or next course you want to see, don't hesitate to drop that in the chat. Thank you.